Hi children, myself Punis CK and thank you for your support for my first video. Today we are going to learn one of the important and interesting lesson of this academics. Better you just take a pen and a notebook to note down some important points. And most important thing is you have to do an activity based on today's session for the FA1. In day-to-day life, many things will follow certain pattern. In our earlier classes, we came across many number patterns. Some of the number patterns I'll write on the board. Just have a look. The first collection of numbers, that is 1, 4, 9, 16, 25 and so on. The second collection of numbers 10, 20, 30, 40, 50, etc. And third collection, that is I can say 2, 3, 5, 7, 9, 10, 11 and so on. And the fourth collection is, that is 4, 6, 8, 9, 10 and so on. So see now, so I have written 4 collection of numbers having some rule. What are the rules hidden among these 4 collections? In the first collection, so this is a collection of square numbers. Just make some squares of every integers, you will get that result. The second collection is a collection of multiples of 10. Because the 10, 20, 30, 40, 50. The third collection is a collection of odd numbers. And the fourth collection is a collection of composite numbers. So what similarity among these three is very simple. They have some definite rule. When the collection of numbers having a definite rule or a certain rule, we can call these collections are sequences, or simply a sequence. To keep in mind what a sequence is. The sequence is a collection of numbers having certain rule. So if the collection of numbers do not have a specified rule, they are just a collection of numbers, there won't be a sequence. I'll give you an example for this one. If you take this example, suppose if I write numbers like this, 2, root 2, minus root 2, root 5, 31, minus 64. So these are the collection of numbers, but they are not a sequence. Why it is not a sequence? Because you can't find any rule there. So now let's define what a sequence is. I'm repeating, sequence is a collection of numbers having some rule for this one, or definite rule you can call it. Next one, suppose if you take one sequence here, so I'll take second sequence, that is 10, 20, 30, 40, 50 and so on. Here each number in the sequence we can call them as, each number in the sequence we can call them as terms of the sequence. So keep in mind what is term. Each number of a sequence is called term of a sequence. The sequence, you can represent each terms by using definite symbols like A1, A2, A3, A4, A5 and etc. As I am reading here, it's a very important thing is the first term represented by A1, the second term is A2, the third term is A3 and the fourth term is A4 and fifth term is A5. It continues. Now just look at these three collection of numbers and also let's identify which is the hidden rule hide inside these three collections. In the first sequence, you will observe that is 10, 20, 30, 40 and 50. There are something consecutive multiples of 10s are there. Which means is very easy to tell. So the second term 20 has been obtained when you had 10 for the what previous one or preceding one. So this some mathematical board, I'll give an idea. It must be you must know about this one. Imagine the 5 is a number. The successive integer of 5 will be 6 and the preceding integer of 5 will be 4. Which means the preceding means 1, previous one, and successive means 1, next one. So this is what mathematical keyword you must know. Now let's have a look here. 20, the preceding number will be 10 and the successive number will be 30. To get 20, you have to add 10 to this. To get 30, you have to add 10 for 20. To get 40, you have to add 10 for 30. And just keep on adding for 10. Which means then the second term and third, fourth, fifth consecutive terms are obtaining when you have fixed number called 10. The second sequence is a bit different. You are adding 10 here. Here you are adding a minus 10 to this. Suppose if you have 10 with minus 10, you will get 0. For 0, if you add minus 10, you will get minus 10. For minus 10, if you add minus 10, you will get minus 20. For minus 20, if you add minus 10, you will get minus 30. Which means here, the fixed number you are adding is 10. Here, the fixed number you are adding is minus 10. Look at the third sequence. So what is a common number or fixed number adding between two numbers? It's very easy to predict. For 10, what should I add to get 10? It's very simple. You have to add 0 for this one, which means 10 plus 0 is 10, 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 which means you added 0. So these are the fixed numbers you are adding for these three sequences to get the next terms. So these kind of collections in mathematics, we can name it as arithmetic progressions. In shortened form, we can name it as AP. So now it's time to define what an AP is. Pay attention. An arithmetic progression is a sequence in which each term is obtained by adding a fixed number to its preceding number except the first term. Now let A1, A2, A3, A4, etc. are in AP. Now just I am telling again, A1 is the first term, A2 is the second, and A3 and so on. If these are in AP, then the first term, the symbol used to represent first term is A. A is equal to A1 and common difference can be found by taking a number, that is a term and its preceding term, that is D is equal to A2 minus A1, that's also equal to A3 minus A2 is equal to A4 minus A3 and keep continuing. So that's what we can find a common difference. So what is the main use of common difference? Remember that the common difference is a tool to detect or to identify whether the given sequence is an AP or not. So let me take an example. Question number 1, check 3, 0, minus 3, 6, minus 6, etc. are in AP. So this is a question. Now I need to check whether this sequence are in AP or not. Now how to find it? So if you find the first term, it won't be used, but you have to find common difference to check whether it's an AP or not. Let's do it. So first, in the case, I'll find the first common difference. D is equal to A2 minus A1. You can say this is the first term, A1, A2, A3, A4. So D is equal to A2 minus A1. Now you just take A2. A2 is 0 here, minus A1 is 3. 0 minus 3 is just minus 3. Let me find another common difference by taking another term and its preceding term. So D is equal to A3 minus A2. That is, here A3 is minus 3 minus A2 is 0. When subtract 0 from minus 3, the minus 3 is going to remain. Since the common difference in both the cases is same, therefore the given sequence is an AP. So that's what. Now let's take an example of an AP. So first term of the sequence is 10, the second one is 15, and third term is 20 and 25 and so on. Now if I ask you to check whether the given sequence is an AP or not, it's very easy for you people now. You just find a common difference between term and its preceding term, and just minimum 2 common differences you find. If you notice it, you will get an idea whether it's the given sequence is an AP or not. So now let me use this sequence to derive something extra in AP. So what is that? Please pay attention. Just I'll collect some data here. Let me call it's A1, it's A2, it's A3 and it's A4, etc. So now the first term here, A is equal to 10, and the common difference is D is equal to, it's 15 minus 10 is equal to 20 minus 15 in both the cases. 15 minus 10 is 5, even 20 minus 15 is 5. So given sequence is an AP right now. So now even D equals 5 and A is equal to 10 here. So let me write the sequence once again here. 10, 15, 20, 25 and so on. Now let's break this in certain pattern. So pay attention now. So I'll keep 10 as it is. The 15 can be written as 10 plus 5, no problem if I write like this. The 20 can be written as what? 10 plus 10, no problem in that. 25 can be written as 10 plus 15 and so on. Now 10 I'll write as it is. 10 plus 5 I'll write as it is. 10, for this 10 still I can split as the 2 into 5. And last one 10 plus 3 into 5 and so on. Here you have to notice what that 10 and 5 is actually stands. Here the 10 stands the first term which represents A, and D stands 5, which means just replace 10 by A and 5 by A, 5 by D. Now 10 we could write it as A, that is A plus D. This is A plus 2 into D. This we could write as A plus 3 into D and so on. At last we can arrange and write it as A, comma A plus D, comma A plus 2D, comma A plus 3D and so on. So this expression is called as a general form of an AP. Keep this in your mind. What is general form of an AP? The general form of an AP is A plus D, A plus 2D, A plus 3D and so on. Now let's recall what we have learned in this session. So first, in the beginning we learned about sequence. As you know that is, you can take it as a small notes here. Sequence is this collection of numbers with certain rule. AP is an abbreviation for arithmetic progression, is a sequence which term is obtained adding fixed number to its preceding one. The common difference is just a constant or fixed number. It might be positive or negative, even 0. So general form of an AP is very important one. A plus D, A plus 2D, A plus 3D and so on. And finally you have an activity today. In this activity what you have to do? See here the activity name tells us the creation of AP by using different A and D, which means you have to choose which is A for you and which is D for you. The first you just choose A and then choose D. Then use this general formula, a general form formula, you will get a result.